For months, astronomers have been tracking 3I/Atlas as it drifts through our solar system, an object that seemed predictable, quiet, and well understood. But something changed, something that shouldn't have happened during perihelion, the point where an object passes closest to the Sun. For months, scientists said the data was stable. Every reading from the observation networks matched the model. But now, a new anomaly has appeared inside the Atlas data stream, and it's forcing researchers to question almost everything they thought they knew about this interstellar visitor. It began with a simple brightness fluctuation. At first, observers thought it was just the sun's reflection, nothing unusual. But when multiple telescopes, positioned thousands of kilometers apart, detected the same deviation at the same moment, the confidence dropped. It wasn't a glitch. Something was happening on or around 3I Atlas. The strange part is the timing. During perihelion, most interstellar objects follow predictable thermal patterns. They heat up, outgas, and lose brightness as dust disperses. But this time, 3I Atlas did the opposite. Its reflective signature increased sharply and then stayed steady, as if something on its surface was actively compensating for solar intensity. Astronomers don't use the word anomaly lightly. To them, it means one thing: data that can't be explained by current models. And this event isn't fitting any existing category. The first clue came from the Hawaii-based Atlas network, the same system that detected the object in the first place. Using high-precision photometry, they noticed what looked like a faint periodic modulation, a repeating flicker, every 19 minutes. A signal like that doesn't usually appear in natural fragments. It's structured, it's rhythmic, almost mechanical. Of course, the community's first reaction was caution. Instruments produce artifacts all the time. Cosmic rays can interfere with readings. But then, two separate observatories, one in Spain and another in Chile, confirmed the exact same pattern. That's when the conversation quietly shifted. For years, many scientists avoided linking 3I/Atlas to anything non-natural. The comparison to Oumuamua was uncomfortable enough. But with this new anomaly appearing during the most critical phase of its solar passage, even the most conservative voices are starting to ask questions. If it's not random, then what could cause a synchronized pattern like that? One theory suggests an internal tumbling motion. Perhaps the object is rotating in a way that exposes reflective surfaces periodically. But the brightness curve doesn't match that. It's too consistent, too uniform. It's as if something is actively controlling the angle of reflection. And that brings us to the more controversial idea, that 3I/Atlas might not be a purely natural body. Harvard astrophysicist Avi Loeb, who has long argued that some interstellar visitors might represent artificial origins, has reportedly reviewed preliminary data from the latest readings. While no public statement has been made, internal sources describe his reaction as cautious but intrigued. If that reaction sounds familiar, it's because it mirrors the tone from 2017, when Oumuamua first passed by and scientists debated its unexplained acceleration. Back then, data showed something small but measurable, a thrust that couldn't be explained by simple outgassing. Now, almost 8 years later, history is seeming to repeat itself. Except this time, the anomaly appeared during perihelion, the most energy-intensive phase of its orbit. If the object were artificial, perihelion would be the exact point where a control system or reflective adjustment might activate. And that's what's raising eyebrows. Some astronomers have even noted that the light pattern resembles a modulation curve, a form of pulse sequence that could, in theory, be used to stabilize attitude or transmit data. Again, nobody's claiming that's what it is, but nobody can yet prove that it isn't. The anomaly's consistency is the real shock. Over 48 hours, more than 12 observing facilities recorded the same periodic flicker. The error margin is now under 1%. That's precision-level alignment. In cosmic terms, it's almost impossible for random dust, ice, or reflection to behave that way. What makes it even stranger is what followed. After perihelion, 3I/Atlas should have begun to cool rapidly, fading as it moved away from the Sun. Instead, the readings held steady, as if the object were still receiving or generating energy. It's as though something aboard or inside was adapting to maintain its thermal balance. Some researchers have privately compared the data curve to controlled reorientation, like an automatic spacecraft adjusting its panels. But officially, no agency has released a statement supporting that. NASA's Minor Planet Center has marked the anomaly as under review. The public doesn't see these internal notes, but scientists around the world are quietly sharing data sets in real time. If the pattern remains stable over the next 2 weeks, it would mean 3I/Atlas is doing something no known natural object has ever done before. Think about that. In all recorded astronomy, nothing this small, this faint, has ever displayed a self-consistent periodic modulation across multiple observatories. If that holds true, it could be the most significant data point since Oumuamua, maybe more. Still, there's another layer that complicates everything. Radar pings from ESA's solar orbiter reportedly bounced off of 3I/Atlas with higher than expected reflectivity. That shouldn't happen if the surface is just rock or ice. It would require a material with metallic or composite properties, something engineered or at least highly unusual. Again, nothing is confirmed, but that's exactly what's keeping the scientific community awake. When objects behave outside expected models, the possibilities expand, and so does the discomfort. Because every alternative explanation demands rethinking what's possible in interstellar travel and what's already passing through our system unnoticed. Some have argued that this might be the first controlled deceleration we've ever seen from an interstellar body. Others warn that it could still be a rare natural phenomenon, something like rotational stress or electrostatic charging from solar radiation. But the real tension lies in what happens next. If the brightness modulation continues as 3I/Atlas exits perihelion and moves toward outbound trajectory, it would prove one thing. Whatever is driving the pattern isn't solar-induced. That would mean it's internal. And if it's internal, then the simplest explanation might also be the most extraordinary. Already, several private observatories are setting up long-range tracking to monitor it over the coming weeks. The challenge is distance. It's now moving farther from the Sun, and optical detection will get harder every day. But radio telescopes are being retuned, searching for narrow band emissions that might align with the modulation frequency. So far, nothing. But that silence might be temporary. If any pattern or repeating signal emerges even once, it would instantly elevate 3I/Atlas from a curiosity to a scientific revolution. For now, the anomaly remains unexplained, but one thing is certain. During perihelion, something happened that shouldn't have happened. The data doesn't lie. The object reacted, emitted, or reflected in a controlled way. And that single event, short, faint, but measurable, is enough to reopen one of the biggest questions in modern science. What if we're not just observing an interstellar rock? What if we're witnessing the behavior of something designed to look like one? Scientists won't make that claim officially. Not yet. But behind closed doors, discussions have already started. Teams are running simulations, comparing trajectories, and matching historical light curves. The goal isn't to prove it's artificial, but to make sure it can't be mistaken for something ordinary. Because once an object crosses that threshold, behaving with intent, consistency, and precision, it forces us to consider that it might have been built, not formed. And if that's true, then 3I/Atlas isn't just passing through our system. It's demonstrating something. The question is, what? Until the next observation window opens, all anyone can do is wait. But this time, the silence feels different. Because for the first time since Oumuamua, scientists have detected an anomaly that doesn't just challenge physics, it hints at purpose. And if that purpose exists, then 3I/Atlas may not be a visitor. It may be a message written in motion, crossing the dark between worlds.